All right, so the next section in Unit 2 deals with systems of equations. So let me introduce them to you. So far we've talked about solving equations with one variable. What happens when we add an extra variable? Well, if I'm asking you to give me the value of two variables, you're going to need two equations. And down the road in Algebra 2, I'm going to ask you for three variables. You'll need three equations, and so on. So a system of equations, that should be an S. This is two or more equations solved simultaneously. Okay, so if I give you two variables, two unknowns, you would need two equations to be able to tell me what each variable represents. The solution, well, for us, it'll be an ordered pair. Because we're dealing with two, that checks both equations. Okay, that means that when you plug in x and y, you get two true statements. Substituting x and y into both equations makes them true. Gives true statements. Oh, I apologize for my handwriting, but you know, what do we do? So here's an example. Suppose I wanted to look at this. Well, I could guess and check if I wanted to, but we're actually going to start with graphing. So I'm going to graph this really quickly, just so you see what we're coming up against. I know my y-intercept is -2. I know my slope is 1 over 1. So I know that this graph will look like this. And today I'm going kind of fast, but I'll go into details about how to graph later this week. So that's what my first equation looks like. My second equation has a y-intercept of 7 and a slope of -2. Oh, and look what happened there. I graphed these two lines, and I noticed that there was an intersection point. This is equation B, right here. So it looks like 3, 1 is a solution to that system. And I can always check it, which I'm going to ask you to do. So if we look at y equals x minus 2, does 1 equal 3 minus 2? Yep. So it checks here. And then I've got to look at equation B. Does y equal -2x plus 7? Well, let's see. Does 1 equal -2 times 3 plus 7? Does 1 equal -6 plus 7? Yeah, man. 1 equals 1. So that checks also. So that means 3, 1 is a solution. But anyway, I'm getting ahead of myself. That's what we're going to get into this week. And if you can knock this out, dude, you're halfway there. Okay, so when we look at graphing, that's where we're going to start. I want you to look here. See where these two lines intersect right there? Okay, well, what's that order pair? 4, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so my solution here is 4, 8. Both of those lines have the ordered pair 4, 8 in their graph. That means when I plug in x equals 4 and y equals 8, I will get a solution. That's all it says. And then notice here, what's that ordered pair? that point of intersection. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. So we went to the left 7, and then we went up 3. So my solution is negative 7, 3. That means when I substitute x equals negative 7 and y equals 3 into the solution, I'll get a true statement. Both of these lines have the ordered pair negative 7, 3. That's all it's saying. And sometimes I'm going to give you a table. And you'll notice here what I'm looking for is a common y. When x is 2, in this equation, I get negative 11. When x is 2 in this equation, I get negative 11. Therefore, my solution is 2, negative 11. Likewise here, when x is negative 3, when I substitute it, I'll get 12. When x is negative 3 here, I'll get 12. When that happens, my solution is x is negative 3, y equals 12. And so just to show you the different variations of graphs and whatnot, let's look at a few, shall we? All right, so let's start with numbers 1 and 2. I want to know what my solutions are. So I look here. What is my common ordered pair? Well, I start at the origin. I went to the left 0, to the right 0, and I went 1, 2, 3, 4, 5, 6, 7. So my solution is 0, 7. Here, where do these intersect? 1, 2, 3, 4, 5, 6, and then down 1. So this is negative 6, negative 1. Okay, Robodeer, you're insulting us. I can pick out points. Yes, you can. But the problem is, after we practice slope, where we move vertically and then horizontally, you may be tempted to write your ordered pairs the same way. But please remember that an ordered pair solution is x comma y. Remember, x, y. So x deals with how do we move left or right, and then the y coordinate deals with how do we move up and down. Don't confuse coordinates with slope, because it happens all the time. All right, so number 3 here. What is my solution? Well, we start at the origin. We go 1, 2, 3, 4 to the right, and then 1, 2, 3, 4, 5 up. So my solution is 4, 5. You know, while we're at it, let's look at number 6 and number 5. All right, so here is my ordered pair solution. I'm going to go to the right, 1, 2, 3, 4, 5. Then I go down 1, 2, 3, 4. So my solution is 5, negative 4, because I had to move down. And in this one, my ordered pair is 1, 2, 3, 4. 4 left, down 1. That's negative 4, negative 1. Then we get to this one. Okay, remember, the solution is where they intersect. So solution means intersect. What happens if there's no intersection? Guess what that means? That means there is no solution. These do not intersect. That means there is no solution. That's my final answer. Okay, now let's look at a few tables. Let's see. Yeah, I can only fit 2 at a time. That's okay. So when I look here, what would be my solution? Where do I have the same x coordinate and the same y coordinate? It looks like it's going to happen here. Because for this equation, I've got the ordered pair 3, 5. And then for this equation, I've got the ordered pair 3, 5. So my solution is 3, 5. And then y'all get to this and you're like, oh no, nope, not doing the fraction. But you'll realize all the work's done for you. All you have to do is find the solution, find the common points. And the common points appear to be here. So when the x-coordinate is -2, both equations have a y-coordinate of -1. That's why that is the solution. And then your eagle eye goes over to number 9. Do I have any common y-coordinates? No, I don't. So I have a feeling this will be no solution. It has to be no solution because if they ended up meeting down the table somewhere, they need to show me that table. But here's what I want you to notice. Look at the slope here. And look at the slope here. You are going to learn that when you have equal slopes, you have no solution. Did we see that here? Well, we saw no solution here. Look at these slopes. Down and to the right, down and, oh, just kidding. That was wrong. I think it looks like it goes here. So we went down 3 to the right 4. Down 3 to the right 4. Look at this line. We went down 3 to the right 4. So it looks like whenever you have equal slopes, you're going to get parallel lines. Equal slopes tell me I have parallel lines. And parallel lines tell me I have no solution. Dang, Robert, you're really knitting together a very pretty conspiracy theory. Yeah, I am, but it's not a theory. It's backed by math. So guess what's going to happen here? We have no solution because we have equal slopes. Okay, so keep that in mind. All right, so file that away for next time. Number 10. Oh, here it is right here. They both have an ordered pair from the table of -2, 2. Here, oh, we both have an ordered pair of 5, -6. Then for number 12 looks a little interesting. I see all these 4s and it kind of shocks me, but it makes sense. When it says y equals 4, all y coordinates are 4. And I'm going to tell you that if we were to graph this, well, let me just show you really quickly. I go over 1, up 4, to the right 2, up 4, to the right 3, up 4. Oh, I forgot 0, 4, 4, 4. Look what's happening. So when you see just y, it's a horizontal line. Guess what's going to happen when you see just x? Yeah, just x will be a vertical line. Let me throw that note in here. No, I'm not going to do that. Just know that when you see just x, it's a vertical line. What I'm looking for here is my solution. And it appears that my solution is 3, 4. So what am I looking for when I'm asking you to solve a system of equations? I'm asking you to find order pairs that make both equations true. So I've already shown you in the table. I've shown you when I've given the graph. You be ready to actually create the graph. And if you're not feeling the graph, I'll show you other methods to solve without graphing. And that's my intro to systems.